We're trying to build the next generation of tools and approaches to basically remove tumors in the most minimally disruptive way. What I've been doing is taking some of the cutting-edge tools from endoscopic instrumentation, small microsurgical instruments, and advances in computer imaging and computer navigation from within the brain to basically create a very patient-specific targeted treatment for every patient's individual problem so that they get the maximal benefit from these advances that we've created in both technology as well as imaging within neurosurgery. My laboratory sits right at the interface of the Department of Engineering and the School of Medicine. How we can utilize those collaborations to build really deep intellectual advancements for treating these neurologic difficulties is something that's really unprecedented, I think, in the country.
What we have here is sort of our flagship project. It's called the Tumor CNC, and it's a device that we believe will help improve the abilities of surgeons to remove tumors in brain surgery. It would take an image of the surgical site, compare that to an MRI image they took beforehand to register the site, and then use a high-powered cutting laser to remove pieces of tissue very fast and very accurately.
So we call this colloquially the tumor ID, but what this does is it unlocks the potential to differentiate tissue based on metabolic differences. And so we know that cancer is going to look metabolically a little bit different, and it's going to behave metabolically a little bit different than healthy tissue, and that'll help us to potentially resect more of the cancer's tissue, which will hopefully increase patient outcomes.
We were looking at things, everything from robotic approaches for neurosurgery, smaller instrumentation to carefully navigate within the head in ways that have never been done before, or even different tools and techniques we can use in the operating room to increase our efficiency or the safety in which we're able to deliver care in the OR.
This will, in the future, we want to enhance the automation skills to assist the surgeon to do neurosurgery in the clinical room.
I think Duke has a very unique position in the country and probably the world when it comes to a real vision for creating collaborations between multiple different medical specialties, research specialties. We've already had technology starting to move forward into the OR that has come about because of these collaborations. A lot of the technological advancements that we're working on don't necessarily find a house in the standard mechanisms of funding that you would see through NIH or government level research. A substantial amount of the work that we do depends on the generous donations of patients, their family, and donors throughout the community. I think everyone realizes the only way that we can solve these problems is to bring all these minds together in the same room and start thinking.